Let's talk about a superpower. It's one you use every single second of every day, and you probably don't even notice you're doing it. It's the secret mental trick that makes language, science, and even your own thoughts possible. We're talking about the power of abstraction. Okay, let's jump right in. Take a look at this. You've got an office chair, a beanbag, a fancy throne, even a simple stool. They're all so different, right? Different shapes, different materials. Some don't even have four legs. And yet your brain, in less than a blink of an eye, just goes, yep, that's a chair. How does it do that? You haven't memorized every single chair on the planet. What you just did was a little bit of everyday magic, an incredible act of abstraction. And that is exactly what we're talking about. Abstraction is your brain's amazing ability to filter out all the messy, specific details, the color, the fabric, the style, and lock onto the fundamental idea. It's grabbing the essential chairness of the thing. It's the engine that takes the chaotic world we see and organizes it into a world that actually makes sense. Now, this whole idea, it's not some new, trendy concept. Not at all. In fact, it's at the very heart of a philosophical debate that's been going on for more than 2,000 years. And it all started with a couple of ancient Greece's heavyweight thinkers. So the big question back then was about these abstract concepts, what they called universals. Are they even real? Plato, for one, argued that they absolutely are. He believed that somewhere out there, in this perfect, timeless realm, there's a perfect form of a chair, and every chair we see down here on Earth is just a flawed copy. But his student, Aristotle, had a different take. He basically brought things back down to earth and said, hold on, the chairness isn't in some other dimension, it's right here, inside every single chair. We figure it out by looking at a bunch of them. Okay, so that's the philosophy, but what's actually happening inside our heads when we do this? Let's switch gears from metaphysics to the modern science of the mind. For a long time, we thought our brains worked like strict accountants, using a checklist. That's the classical view. To be a triangle, an object must have three sides. Simple, right? But what about a fuzzy category like bird? A penguin is a bird, but it doesn't fly. An ostrich is massive. That's where a new idea called prototype theory comes in, and it's so clever. It suggests our brain doesn't use a rigid checklist. Instead, it creates an ideal prototype, like the perfect mental image of a bird, say a robin. And then it judges everything else based on how close it is to that prototype. And that right there is why a penguin feels a little less birdy than a robin does. And our brain organizes all these concepts into this neat little filing system. But the really interesting part here is that middle one, the basic level. This is our brain's sweet spot. It's the most efficient category. It gives us the most useful information for the least amount of mental effort. It's the whole reason why little kids learn to say dog long before they say animal or poodle. It's just the default level our brains love to operate on. So, we've talked about the software, the models of how we form concepts. But what about the hardware? Where is all this heavy lifting actually taking place? Well, the answer is right at the front of your head, in the brain's command and control center, the prefrontal cortex. And even inside the prefrontal cortex, there's a clear division of labor. Think of it like a company's org chart. The back part, the posterior cortex, is like someone on the factory floor. It handles very direct, concrete rules. See a circle, press the left button. Simple. But as you move forward, toward the very front, you're heading up to the CEO's office. This is where the big picture, abstract goals get managed, the overall strategy for everything you're doing. So why do we have this incredible mental machinery? Well, it didn't just pop up out of nowhere so we could think about philosophy. It was forged in the fires of evolution. This wasn't a luxury, it was a weapon for survival. And that's the core of the cognitive niche hypothesis. You see, early humans, we weren't the fastest or the strongest animals out on the savannah. We couldn't outrun a lion. We couldn't outmuscle a mammoth. So what did we do? We outthought them. Our ability to think abstractly, to see cause and effect, to plan for the future, to work together, let us build tools and traps and strategies that eventually made us the planet's top predator. And if you look at the archaeological record, you can see this wasn't some sudden big bang of genius. It was a long, slow burn. 1 million years ago, our ancestors took the idea of a sharp edge from stone and applied it to a completely different material, bone. That's a huge abstract leap. Fast forward to 72,000 years ago, and we see the first clear evidence of symbols, things like pierced shells used as jewelry, probably to signal who you were and what group you belong to. That's abstraction you can hold in your hand. So that brings our journey all the way up to today. and it tees up one of the biggest, most fascinating questions of our time. We've built these incredible machines that can crunch unfathomable amounts of data. But can they actually think abstractly the way a human does? And here's where we get to the fundamental difference. Human thought is embodied. We learn things because we live in the physical world and interact with it. We understand what hot means because we've actually felt warmth. An AI, on the other hand, learns by spotting statistical patterns in huge piles of text and images. It knows the word hot appears near the word stove, but it has never, ever felt the heat. So to really dig into this difference, researchers came up with this brilliant test called ARC. It's basically a set of totally unique visual puzzles. They're designed so that an AI would have never seen anything like them in its training data. The whole point is to reward genuine, flexible reasoning and to completely stump the kind of statistical shortcuts that AIs are so good at. And the results are absolutely fascinating. Sure, an AI can sometimes get the right answer, but how it gets there is completely alien. Humans look at a puzzle and flexibly search for the core principle, the underlying rule. The AI just looks for superficial shortcuts that happen to work for that one problem. And look at the learning speed. When humans get a second try, they get way better because they actually learn the rule. The AI, it doesn't improve at all, not really. It doesn't learn from its mistakes in that deep, meaningful way. But here it is. Here's the most stunning statistic of all. While the world's best AIs are stumped by a lot of these puzzles, researchers found that for 98.8% of them, at least one human participant could figure it out. Just think about what that means. This incredible, flexible, abstract problem solving, it isn't some rare skill for geniuses. It is a deeply, almost universally human ability. It's part of our standard toolkit. Which leaves us with this final massive question. We've gone from Plato's world of perfect ideas all the way to the wiring of our own brains and the frontiers of AI. And what we've seen is that abstraction isn't just about being smart, it's about a search for meaning, for the rules that govern the world. So as AI gets better and better at copying the results of human thought, we have to ask, can a machine that only learns from patterns ever truly bridge that gap and learn to search for meaning? The answer to that is going to define our future.